Okay, so we want to find the area of this pentagon. It's a regular pentagon, and we have to use this equation. Now, yeah, there are always other techniques, but for now, we're just going to use the apothem to help us find it, and we need to figure out the area. We know one piece of information. Now, I drew kind of the pentagon. I did my best to kind of get it to be a perfect pentagon in terms of its angle measures, but so we know that we need to find the central angle in this, and let's just understand what that means. It means that I'm just going to create all these triangles in this diagram, right? And I can just kind of go from the center to the vertice. And what does that create for me? It creates 5 congruent triangles, and that's really ultimately the main idea of what's going on here. I have these 5 triangles, all should have the same area each, and then the 5 of them together make the big shape, right? So if I know the radius, I can kind of go back to what we learned, and I do need to calculate the apothem, which is the distance from the center to kind of the midpoint of the edge of the side, right? And so it should create a situation where I have this equal to this. This is perpendicular bisector of that. So and so what we want to do is just pull out one triangle. So I'm going to pull out this triangle, the one that's kind of I drew with a right angle and those two things. And we also know that this is congruent to this. So when I pull that triangle out, right, I have this side congruent to this side. I have the apothem, which we don't know the value of that, but I do have this congruent to this, and I know that this side is 8, right? And of course I know that this side is 8. I don't know anything else, except I can go back to the central angle, right? And notice that all of these angles, 1, 2, 3, 4, 5, because there's 5 triangles, this one was split into 2, I can say that 360 degrees divided by 5 will give me the central angle, and 300 goes into it 72 times, right? So I know that the central angle, each of these central angles are 72 degrees. So this angle right here, 72 degrees. So this should be a right angle. So of course we always want to kind of take the approach that we're going to break the triangle apart a little bit, and so I'm going to take again the right half of the triangle. Again, could I take the left half? Yeah, but I'm right-handed, so I think maybe that makes it easier. So this is 36 degrees because it's half of 72. I know that this is 8, and so I need to find the apothem, but then I also need to kind of find the side here. Now the side is only, right, it's this letter S and then this letter S, so that's important for calculating the total distance around, for finding the perimeter of the shape, knowing that I have 2 of these here, which would mean that I have 2 for each of these big triangles, so 10 total, but we'll get to that as we work it out. So I can't use the special right triangle rule since my angle measure is 36 degrees, so I do need to kind of consider that I need to use other techniques, and so I can go back to something hopefully you have learned through your practice, SOHCAHTOA as a technique for figuring out which trigonometric ratios I want to use to calculate this. And so of course this is the sine, this is the cosine, and this is the tangent. So if you have not seen these techniques, you should watch the video about it. But so when I look at this, I see that the A, which is the apothem, is also adjacent to that angle. So the cosine of 36 is going to be equal, right? And cosine is adjacent over hypotenuse. So the cosine of 36 is equal to adjacent A over 8. And so if I want to just figure out what A is, I can just find it this way. So this is my value of my apothem. So I'm going to go to the formula, and I can say 1/2 apothem times perimeter, and then I can plug in my apothem that I just found. I'll use parentheses to do that. Okay, so but I still have to figure out what my perimeter is. So we can look here, and the perimeter segment, right? This segment right here is across. It's opposite the angle. So I know that I'm going to go up here, and opposite is O, so I'm using my sine function, opposite over hypotenuse. Now there is an opposite here, but the 8 is given, so that's why I use the hypotenuse. So I can say that the sine of 36 is equal to the side segment over 8, and then of course we can apply that same approach here. So we get S equals 8 times the sine of 36 for our segment. Now I'm putting it in brackets instead of a box because this is only part of our line. So it's this right here is just this right here, which is just this right here. And so it's how many sides do I have on my 5-sided shape? 5 sides, right? So, but for each side I have 2 of these. So the perimeter, I actually have to multiply this value here by 10 because I have 10 of those little segments. Now the brackets just act as parentheses, so they can drop since everything here is being multiplied, or I guess divided in this sense. So I can group all the values without the trig functions, and so I'm going to kind of do that. I'm going to say 8 times 10 times 8 divided by 2, and then I have times the cosine of 36 times the sine of 36. And of course this can just be simplified. I have 40 times 8, so I get 320 times the cosine of 36 times the sine of 36. And then I can break out the calculator to figure that out, and I can say 320 times 36 cosine, and then I want to times 36 sine, and then depending on what you want to round to, I find the area of this shape to be 152 point, if I round it to the tens place, 0.2. So that is one technique to do it, and that should help with recognizing the process.